I'm pleased to be here, especially in a workshop in honor of Mariano Artigas, whom I've known, I think I first met at Berkeley, California, at a meeting for the Templeton Foundation back in the mid-1990s. And I've been twice as his guest at the Universidad de Navarra, so I've had lots of opportunities to speak with him on a wide range of topics. Today, I want to talk about creation and inertia and the scientific revolution and the ways in which understandings of those three, creation, inertia, and the scientific revolution, have come to inform or really misinform contemporary discourse on science and religion. And there is a handout with some text. In many ways, we've come to understand the scientific revolution of the 17th century as a watershed event in the history of the West, as an event, or better, a series of interconnected events which has produced the modern world. The stories we tell about what it means to be modern are frequently laced with references to the rise of modern science, associated with towering figures such as Galileo and Newton, or of the advent of modern philosophy in which the name of Descartes is revered. There seems to be little doubt that the 17th century witnessed a turning point in intellectual history, a turning point which in every sense was epoch-making. As a result of this turning, we live, so it is often claimed, in a world irreducibly different from the one animated by Aristotelian and Thomistic thought. So distant are we, at least in conceptual terms, that any appeal to principles of science and philosophy associated with that other world is rejected. Thus, if in following in the tradition of Mariano Artigas, we were to seek to engage in an informed dialogue between science and religion, we run into a barrier which needs to be overcome if we wish to take seriously what Aristotle and Thomas and others living before the advent of modernity had to say about nature, human nature, and God. And in my presentation today, I want to confront this barrier head-on. I want to examine the adequacy of the commonly accepted interpretation of the rise of modern science as involving necessarily a rejection of the science of Aristotle and his medieval successors. Many of the interpretations of the rise of modern science involve fundamental questions about the relationship between faith and reason, and they tend to include the view that the modern world is the result of the victory of a rational, scientific conception of nature and human nature, a victory which at least had its beginnings in the 17th century. Furthermore, for many, the rise of modern science is inextricably linked with materialism, mechanism, and reductionism, a linkage which I think finds justification in a philosophy of nature, which itself is supported by a particular interpretation of the history of science. There is a broad historical claim, widely accepted, which is at issue here, to which I've already alluded, namely that the rise of modern science involves a rejection of Aristotelian science. A modern scientific conception has emerged, so versions of this grand interpretation would have it, precisely by rejecting as false or irrelevant conceptions of nature and human nature at the core of an Aristotelian and Thomistic worldview. According to such an understanding of the scientific revolution, any appeal to what Aristotle or Thomas Aquinas would say about the natural sciences is irrelevant, since there is a deep gulf, a fundamental incompatibility between an Aristotelian notion of nature and the understanding of nature ushered in by modern science. I want to identify a set of underlying presuppositions of modernity and science which thus tend to prevent us from examining a Thomistic worldview, except perhaps as a kind of idle curiosity. Ultimately, I hope to offer an opening, a kind of intellectual space for taking seriously a concept of nature which finds its roots in Aristotle and its flowering in Thomas Aquinas. Let me begin by calling your attention to a standard rendering of what we might call the master narrative of the scientific revolution. And this is quotation number 1 in your handout, a text from Herbert Butterfield writing a little more than 50 years ago. Butterfield writes, "Because the scientific revolution overturned the authority in science, not only of the Middle Ages, but of the ancient world, since it ended not only in the eclipse of scholastic philosophy, but in the destruction of Aristotelian physics, it outshines everything since the rise of Christianity and reduces the Renaissance and Reformation to the rank of mere episodes, mere internal displacements within the system of medieval Christendom. Since it changed the character of men's habitual operations, even in the conduct of the non-material sciences, while transforming the whole diagram of the physical universe and the very texture of human life itself, it looms so large as the real origin of the modern world and of the modern mentality that our customary periodization of European history has become an anachronism and an encumbrance." Now, although we may be less enthusiastic than Butterfield in his characterization of the importance of the scientific revolution, we ought to recognize in his comments the prevailing view of the scientific revolution as the overthrow of Aristotelian science. We may well accept Thomas Kuhn's description of this revolution as a paradigm shift, and thus react skeptically to claims which conclude that Aristotle's science was false and modern science true. But nevertheless, the master narrative remains intact, since in Kuhn's view there is an incommensurability between the old and the new paradigms. We might follow Pierre Duhem, who locates the real revolution in 14th century Paris, the result in part of the condemnations of Paris of 1277. Or we might follow Alexander Koyré, who interprets the revolution in terms of a grand metaphysical shift from Aristotelian to Platonic metaphysics, from the closed world to an infinite universe. Yet there remains little doubt that a major intellectual and cultural transformation occurred. Last year's recipient of the Templeton Prize, Michael Heller, Polish mathematician, cosmologist, and Catholic priest, has frequently noted that the rise of modern science has its source in a mathematical, experimental view of nature founded on premises, quote, "which do not conform to and are actually incompatible with the philosophical position of Aristotle and Aquinas." He continues, "Any attempt today to retrieve that tradition is doomed to failure." Sober words for what I want to wish to argue today. And he has $1,250,000 behind that comment. Well, the principle of inertia and modernity. The standard version of the master narrative tells the story of how Galileo and Newton overturned the antiquated Aristotelian view of the universe and established the principles of modern science. Although the master narrative has many subdivisions, it will be useful to focus on what is regarded as the very first principle of the new physics, the principle of inertia. Every body perseveres in the state of rest or of uniform motion in a straight line unless it is compelled to change that state by forces impressed upon it. Alfred North Whitehead called the principle of inertia the first article of the creed of science, and like the Church's creed, it is more than a mere statement of belief. It is a paean of triumph over defeated heretics. And the defeated heretics, Whitehead explains, are the Aristotelians, who for 2,000 years imposed on dynamics the search for a physical cause of motion. According to this interpretation, Newton's principle of inertia contradicts Aristotle's principle that everything which is moved by another. If Newton is right, Aristotle must be wrong. Contemporary commentary on the relationship between traditional theology and the natural sciences has been heavily influenced by the orthodox interpretation of the scientific revolution as a radical rupture in the history of science. Anthony Kenny, for example, denies the probative force of Aquinas' proofs for the existence of God because these proofs are based on the principles of Aristotelian science, a science which the modern world has shown to be false. And this is the second quotation in Roman numeral 2 from Kenny. Newton's law of inertia wrecks the argument of the first way, for at any given time, the rectilinear uniform motion of a body can be explained by the principle of inertia in terms of the body's own previous motion without any appeal to any other agent. And there seems to be no a priori reason why this explanatory process should not go backwards forever. Newton's law will not explain how motion began, but how do we know that motion had a beginning? In volume 3 of his recent work, A New History of Western Philosophy, Kenny argues that Galileo, Descartes, and Newton were able to show that the principle fundamental to Aristotelian physics, that nothing moves unless acted upon by an external mover, that principle is false. Kenny admits that the liberation of physics from the erroneous principles of Aristotelian physics, quote, was accompanied by an impoverishment of philosophy. He continues, though Aristotle's scientific physics was shown to be very largely mistaken, his conceptual scheme retained much value. All too often, Kenny writes, both good and bad were thrown overboard together. Here, Kenny suggests a useful distinction between what he calls two disciplines, a kind of broad philosophy of nature concerning general concepts such as space, time, motion, and change, and a distinctly science of physics. Nevertheless, I think that Kenny's analysis suffers because he accepts, at least in part, what I've called the standard narrative of the scientific revolution. That there are broad philosophical and theological implications of Newtonian physics, especially concerning the doctrine of creation, is evident in the analysis of a particularly influential contemporary theologian, Wolfhart Pannenberg. Pannenberg claims that the acceptance of the principle of inertia in the 17th century represents not only a radical break in the history of science, but is also a fundamental problem for the Christian doctrine of creation. According to Pannenberg, the principle of inertia lies behind a denial of the radical contingency of the world, a contingency central to the doctrine of creation. Creation means that the world is contingent. Modern science, as it developed in the 17th century, denies this principle of contingency, so Pannenberg. Furthermore, as he remarks, quote, any contemporary discussion regarding theology and science should first focus on the question of what modern science, and especially modern physics, can say about the contingency of the world as a whole and every part in it. Only if science reveals a contingent universe can there be room for a doctrine of creation. Although Pannenberg thinks that contemporary field theory in physics, unlike the principle of inertia, does allow for a radical contingency in nature, I want to point to what he claims to be the original significance of the principle of inertia for the doctrine of creation. Pannenberg observes that, especially with Descartes, the principle of inertia, quote, leads to an emancipation of the natural processes from their dependence on God, even though the general framework of Descartes' ideas on the creation of the world and on the world's need for continuous preservation by God still quite traditional. It was, of course, Descartes who referred to inertia as the first law of nature. Descartes did take the law of inertia to be a manifestation of the immutability of God, but the seeds are sown, according to Pannenberg, for the eventual affirmation of the autonomy of the world and its processes. It was Newton's understanding of inertia in terms of a force that is inherent in bodies, along with the reduction of force to a body and its mass, that contributed in a decisive way in the course of the 18th century to the removal of God from the explanation of nature. This is 3A on your handout from Pannenberg. The emancipation from the creator God entailed in the principle of inertia did not apply only to natural bodies and beings which at the same time continued to undergo influences from outside themselves. Even more serious was the consequence that the system of the natural universe had to be conceived now as an interplay between finite bodies and forces without further need for recourse to God. Now, the source of Pannenberg's understanding of the importance of the principle of inertia for the Christian doctrine of creation is the work of another German thinker, Hans Blumenberg. In two major books, The Legitimacy of the Modern Age and The Genesis of the Copernican World, Blumenberg ranges widely in philosophy, the natural sciences, theology, and political thought, and literature, as he examines the transition from the medieval to the modern world. For Blumenberg, the novelty of modernity is to be found in what he calls the reoccupation of prior explanations of time, nature, and God. Let me offer an example of what Blumenberg means. The modern commitment to human autonomy and self-assertion is, for Blumenberg, a response to claims of divine omnipotence, of the absolute power of God, characteristic of nominalist thought. Such affirmation of divine omnipotence necessarily entailed a denial of an intelligible order of nature discovered by human reason. The utter contingency of a world dependent upon the absolute will of God is, according to Blumenberg, quote, a disappearance of order which causes doubt regarding the existence of a structure of reality that can be related to man and makes the traditional conception of human activity bound up in the ancient and medieval cosmos no longer workable. So the 14th century development of nominalism prepares for the modern notion of human autonomy, as we'll see in a moment, and prepares for it by destroying the intelligibility of the medieval cosmos. And this is 3B on your handout. The modern age has regarded self-preservation as a fundamental category of everything in existence, and has found this borne out all the way from the principle of inertia in physics to the biological structure of drives and the laws of state building. Blumenberg thinks that the early modern mechanistic explanation of nature, with its commitment to absolute matter, reoccupies the position of the late medieval nominalist mode of explanation based on absolute divine will. Self-assertion and human autonomy are the broader cultural correlatives of a fundamentally new principle of explanation. And for Blumenberg, it is the principle of inertia which lies at the core of this new view of things. With the principle of inertia, there is in all things, in all matter that is, an inherent force of self-preservation. And it is this scientific revolution associated with the principle of inertia which lays the foundation for the whole cultural project of modernity. So the incompatibility between the principle of inertia and the doctrine of creation, which Blumenberg and Pannenberg see as a characteristic feature of the modern age, that incompatibility rests upon, at the very least, a misunderstanding of creation. In their analysis, creation is really a kind of change, and the creator functions as one more agent not fundamentally different from other agents in the world of change. Both will speak of God as a transcendent agent, but God's creative actions in the world are causes which differ only in degree from other efficient causes. God's role as unmoved mover, for example, is necessary for medieval Aristotelian physics because the science of nature requires God's agency in order to explain motion. Thus, Blumenberg and Pannenberg think that an appeal to God's agency is irrelevant, or at least is seen to be irrelevant, in a world operating according to the principle of inertia, since, so the argument goes, the principle of inertia means that there is no reason to seek a continuing cause of motion. As Blumenberg says, God's function as conserver of the natural world is rendered superfluous. God's agency in conserving things in being is, for Blumenberg, not really a different kind of agency from God's causing motion. You don't need God to cause motion. You don't need God to conserve being. There is in this analysis a failure to grasp the analogical notion of cause, not to mention the special kind of analogy needed when cause is predicated of God. An important error in this analysis is to consider creation a kind of change. Thomas Aquinas, throughout his discussion of creation, was always careful to point out that creation is not a change. Rather, it is a metaphysical dependence in the order of being. So the natural sciences, whether Aristotelian, Newtonian, or contemporary, have as their subject the world of changing things, from subatomic particles to acorns to galaxies. Whenever there is a change, there must be something which changes. But for Thomas, to create means to be the radical cause of the whole reality of whatever exists. To cause completely something to exist is not to produce a change in something. To create, thus, is not to work on or with some already existing material. Creation is not exclusively, not even primarily, some distant event. It is the continual, complete causing of the existence of whatever is. This metaphysical dependence is the same throughout the being's existence as it is at its beginning. The traditional doctrine of creation remains unaffected by any conclusion whatsoever in the natural sciences, including the principle of inertia, for example, since creation is a metaphysical notion, not a physical one. To think that the continuing reality of any motion or change or of state of rest does not need an explanation in terms of cause, and that's precisely the interpretation given to Newton's principle of inertia. To think that the continuing reality does not need a cause does not mean that the continuing existence of all that is, as it exists, in whatever way it exists, does not require the causality of God as a creator. So what I'm arguing here is that they take the standard interpretation of the scientific revolution, they focus on the principle of inertia, and they tell us that the principle of inertia is incompatible with the doctrine of creation. And what I'm trying to suggest here is, regardless of the standard interpretation of the scientific revolution, their notion of the incompatibility of the principle of inertia with the doctrine of creation rests, first of all, on a misunderstanding of what creation is. So that whatever self-sufficiency we might find in nature is not an absolute self-sufficiency. It is only a self-sufficiency with respect to the principles of the natural sciences, but not with respect to God as the cause of all that is. Now, in addition to a confusion about the proper meaning of creation, Blumenberg and Pannenberg, in their analysis of the principle of inertia as the foundation of modernity, share the standard interpretation of the scientific revolution as a rejection of Aristotelian physics. And it's this subject now, the standard interpretation of the scientific revolution, which I wish to spend the rest of my time. If there is a fundamental incompatibility or incommensurability between Aristotelian science and modern science, then any philosophical reflection rooted in or employing principles from Aristotelian science must either be rejected or radically reformulated. Often I participate in conferences on the relationship between religion and science, in which speakers refer to, quote, the Newtonian Settlement as the basis for modern philosophy and theology. This is a phrase from Bob Russell of Berkeley, the Newtonian Settlement. This settlement tends to rule out appeals to Aristotelian and Thomistic natural philosophy, since, so the argument goes, such a philosophy has been rendered false by modern science. No room for it in the house of modern science. This helps to explain why in the 17th and 18th centuries it was apparent to many that only a mechanistic philosophy of nature could meet the evidence of modern science. Indeed, early proponents of mechanism, especially in the 17th century, saw it as a way to reconcile their belief in God with the insights of Newtonian science. The great interest in mechanism in the especially in the 17th and 18th century had theological motivations. And more frequently today, process thought is urged as providing the necessary philosophical complement to the natural sciences. Form and matter, substance and accident, teleology and the like are thus all seen as part of a view of the world, which, thanks to the scientific revolution, we know is wrong. As we've seen, nowhere is the rejection of Aristotelian physics more evident, so the master narrative of the scientific revolution would have it, than in the principle of inertia, which, so it seems, directly contradicts the fundamental Aristotelian principle that everything that is moved by another. If we turn to the principle of inertia and examine it in some detail, we can confront the thesis of a fundamental incompatibility between Aristotelian science and Newtonian science. Such an analysis, I think, will offer evidence against the view that to accept modern science, one must reject Aristotelian science. Newton's famous three laws of motion appear early in the Principia. He begins with a series of definitions concerning mass, forces, and the like, then states the three laws and deduces corollaries from them. These laws, corollaries, and definitions are expressed in expository prose, without those mathematical equations with which we may have become familiar. In the preface, Newton reminds the reader that in this work he will, quote, subject the phenomena of nature to the laws of mathematics. At another point he observes that he only provides, quote, a mathematical notion of forces without considering their physical causes. He tells us that he is considering, quote, forces not physically, but mathematically. At the beginning of Book 3 of the Principia, the section called The System of the World, Newton notes, quote, in the preceding books I have laid down principles not philosophical, but mathematical. When he turns to discuss various explanations of planetary movement, he notes the ancient view of the planets being embedded in solid orbs. Newton thinks that Descartes and Kepler postulated celestial vortices as a way to account for such motion. And then he continues, quote, from the first law of motion, principle of inertia, from the first law of motion, it is very certain that some force is required. But our purpose is to bring out its quantity and properties and to investigate mathematically its effects on moving bodies. Although Newton was convinced of the tremendous power of mathematics to discover and describe accurately certain fundamental characteristics of the world, we must not think that Newton was some 17th century Pythagorean for whom the mathematical description of reality is the only truly scientific account of nature. Newton warns against such an attribution when he remarks, and this is quotation 4a on your handout, Those violate the accuracy of language, which ought to be kept precise, who interpret these words, time, space, place, and motion, for the measured quantities. Nor do those less defile the purity of mathematical and philosophical truths who confound real quantities with their relations and sensible measures. Immediately prior to his enunciation of the principle of inertia, Newton provides a definition of centripetal force, in which he hypothesizes what would happen in projectile motion if the resistance of the air is taken away. A common problem in ancient and medieval and some early modern physics, what is happening when you throw an object, projectile motion. What would happen, he hypothesizes, what would happen if the resistance of air is taken away? In this discussion, Newton moves from the world of ordinary experience, of throwing objects, he moves from the world of ordinary experience to imagine the limiting case of motion, namely that at which the projectile would proceed in its motion forever. Remember the principle of inertia? Something in motion will continue forever unless affected by another force. Newton describes what obtains in a limiting case, when all resistance is removed. And thus he presupposes the concept of limit in the derivation of that case. Newton's notion of limit, which is embedded in the principle of inertia, Newton's notion of limit is drawn from mathematical modes of reasoning. It is precisely such a mathematical concept of limit which is at the root of the principle of inertia. The principle of inertia is an inference drawn from the mathematical physical approach to a limit. What would happen if all resistance is removed? In other words, as the resistance of the medium approaches zero, the distance traveled approaches infinity. As an idealized, quasi-mathematical concept, the principle of inertia involves an abstraction from the extrinsic forces acting on real bodies moving in a physical environment. The principle of inertia also involves an abstraction from any kind of physical causality. Accordingly, the principle of inertia, regardless of its truth, says nothing in support of, nor in contradiction to, Aristotle's principle in physics that everything that is moved by another. There is no explicit discussion in the Principia about the need for an extrinsic cause of motion, apart from what Newton says about God as universal mover. Nevertheless, in some reflections on mechanics at the end of the optics, Newton observes, and this is 4b on your handout, that his inertia is a passive principle by which bodies persist in their motion or rest, receive motion in proportion to the force impressing it, and resist as much as they are resisted. By this principle alone, there never could be any motion in the world. Some other principle was necessary for putting bodies in motion, and now they are in motion, some other principle is necessary for conserving motion. The principle of inertia considers bodies simply as three-dimensional realities devoid of natures. Such an abstraction from nature is possible and appropriate in the mathematical study of nature. In an unpublished work, early work, Newton commented on the kind of entities which mathematical physics considered, and this is 4c. Moreover, since body is here proposed for investigation, not insofar as it is a physical substance endowed with sensible qualities, but only insofar as it is extended, mobile and impenetrable, I have not defined it in a philosophical matter, but abstracting from sensible qualities, I have postulated only the properties required for locomotion, so that instead of physical bodies, you may understand abstract figures in the same way that they are considered by geometers when they assign motion to them. Well, in the universe in which we live, there are no nude bodies devoid of natures, and there are no bodies in uniform motion in a straight line forever. Newton's first law of motion cannot be a law of nature, least of all the prima lex naturae, the first law of nature that Descartes thought necessary in his universe of geometrical space. But Descartes' principle of inertia, his first law of nature, is not Newton's principle of inertia. Only in such a Cartesian world of nude bodies, each with a fixed quantity of matter and a fixed quantity of motion, can there be such a first law of nature. But as I've said, the Cartesian world is not Newton's world, and Descartes' notion of inertia is not Newton's, even though the words are very similar. But only if one assumes that the principle of inertia is a law of nature, and not simply a principle in mathematical physics, would one have a problem with its relationship to Aristotelian physics. The application of mathematics to the study of motion necessarily involves an abstract world. And an abstract world is surely not a false world, but nor is it identical with the world of nature. Newton knew full well that when he, for example, defined mass as the quantity of matter and momentum as the quantity of motion, that he was proceeding in the realm of mathematical physics. Obviously, we should take a clue from the title of his work, Mathematical Principles of Natural Philosophy, which differs in a crucial way from Descartes' title, Principles of Philosophy. We should recognize that in Newton there is not so much a rejection of the principles of Aristotelian physics as a great expansion of and sophistication in the science of mathematical physics. Although for Aristotle and Aquinas, mathematics and physics are autonomous and distinct sciences, one may apply mathematical principles to the study of natural phenomena. Such applications occur in neither the science of mathematics nor in physics. They constitute mixed sciences, types of knowledge that are intermediate between what we today might term pure mathematics and a more general science of nature. Aristotle, in the second book of the Physics, recognizes the legitimacy of such intermediate sciences, what he considers to be, in some sense, branches of mathematics which come nearest to the study of nature, and he lists optics, harmonics, and astronomy. In referring to such a mixed science, Aquinas writes, and this is 4D on your handout, his commentary on Boethius' De Celeritate, it does not belong to the mathematician to treat of motion, although mathematical principles can be applied to motion. The measurements of motions are studies in the intermediate sciences between mathematics and natural science. It seems to me, and here I'm following William Wallace, James Weishaupt, and some other North American Dominicans who've written extensively on this. It seems to me that we can best understand the history of science the 14th through the 17th centuries, and indeed beyond to our own time, if we recognize that some of the greatest accomplishments in the sciences have taken place in mathematical physics, that intermediate science, or sciences, between mathematics and physics. The developments in the natural sciences in the 17th century, most apparent in the field of physics, do not so much represent a rejection of the principles of Aristotelian physics as they mark a great advance in our understanding in the ways in which mathematics can be applied to the study of physical reality. The sciences of Galileo and Newton, strikingly original as they are, remain, I think, fully consistent with the general Aristotelian science of nature. The philosophical baggage of a mechanistic and materialistic natural philosophy, which is often associated with modern science, is the product of philosophical traditions in the 17th century and beyond. Mechanism and materialism do represent a radical rejection of Aristotelian and Thomistic natural philosophy, but mechanism and materialism remain excess baggage for which the airlines would charge a lot. Excess baggage not required in order to accept the advances in our understanding of the world, which are the legacy of Galileo and Newton. Now, misinterpretations of the scientific revolution, and I've tried to suggest with respect to the principle of inertia, a core misinterpretation, but misinterpretations of the scientific revolution have also tempted some in the Thomistic tradition to retreat from the arena of natural philosophy to bask in the seemingly safer and ethereal realm of metaphysics. The history of science can help us distinguish between the advances of modern science, the mechanistic and materialist natural philosophy which has accompanied these advances, and the principles of Thomistic natural philosophy which can lead to a deeper and more complete understanding of nature, human nature, and God. Distinguishing between the developments in mathematical physics from the philosophical baggage often associated with the scientific revolution allows us to avoid the error of thinking that the rise and development of modern science renders useless the philosophical insights of Aristotle, Thomas Aquinas, and others, people like Anthony Kenny and many others. And Alasdair MacIntyre, for example, falls into this category of misunderstanding the scientific revolution. I hope that I've shown how a knowledge of the history of science, which was always important for Mariano Artigas, is crucial when one raises difficult questions in natural philosophy and metaphysics, and in theology as well. I have not argued directly for the cogency of the metaphysics and natural philosophy in the Aristotelian Thomistic tradition, an argument for the cogency of concepts such as substance and form and matter and teleology. I've not argued for that here, but I've tried to lay the proper groundwork for continuing to take seriously the claims of that tradition. Thank you.
Thinking when Bill made one of his later remarks that he has a future, perhaps, if he has no other future, perhaps in the public relations department of Ryanair, in the justification of excess baggage. We'll now have observations and discussion, but I may not know the names of everyone, anyone who may attract my attention. If I do know your name, fine. If I fail to give your name, please give it. Then we actually know who has actually answered the question. So
I'm going to give this for recording.
Ah, very good. So who wants to chip in first? Yes. Remind me of your name.
My name is Jitse van der Meer.
Right, Jitse van der Meer.
Thank you very much, Bill, for a stimulating paper. Your thesis, as I understand it, is that Newton didn't make it superfluous to talk about God as the first mover. What I wonder about is how to take that thesis in light of what you said at in the first few minutes of your paper, where you talked about the doctrine of creation and how you can understand that not in causal terms, but God as the ground of existence, because that makes the sort of causal approach to God's involvement unnecessary. So I wonder about why you developed the thesis you did in light of that first comment.
The first point I talked about concerning creation has to do with the interpretations of Pannenberg and Blumenberg, who expand the principle of inertia to reach the conclusion that one necessarily denies a doctrine of creation if one embraces the principle of inertia, because it means we don't need a cause outside of the causes in the natural order. The question that you asked really concerns what is the relationship between an argument from motion to an unmoved mover and an argument for creation. There would be some scholars of Thomas Aquinas who think that the argument from motion to unmoved mover is ultimately an argument in metaphysics and not an argument in natural philosophy or physics. I wouldn't be in that category. But for Thomas, an understanding of creation as metaphysical dependence begins, has a beginning in an argument from motion to an unmoved mover, and cause of motion is then expanded in metaphysics to be understood as cause of being. So Thomas thinks that in natural philosophy alone, in Aristotelian physics alone, one can come to know that there is a God as cause of motion. That's a more limited understanding of God's causality than what comes in the doctrine of creation. All right? So how Thomas moves from an argument from motion to unmoved mover to an argument, a full-blown metaphysical argument for creation, will involve notions of participation, much broader discussions in metaphysics. As I said, there would be some people, famous scholars of Aristotle, like Joseph Owens in Toronto, Father Whipple at Catholic University of America, and others who would think that that first argument of the five ways really only works if it's an argument in metaphysics. But I think that that's really not, that certainly isn't what Thomas proposes. And I think finally Thomas is correct that the argument in natural philosophy can lead us to an unmoved mover. But my point is that that conclusion, that there is an unmoved mover, and that's at least what we mean by God, is then expanded into a fuller understanding of creation, which is more than just cause of motion, but rather cause of being. But surely once you have the full doctrine of creation, then surely since motion is an existing reality, and that is included in a doctrine of creation.
Steve Fuller.
Yeah. I now realize why we're in the session together, because my take on this is quite different, and I just want to flag something that you mentioned, and I understand what you've done here is basically kind of assimilated Newtonian physics into the Thomistic worldview and show how it can be made compatible and reconcilable and so forth. I mean, I think that's kind of the thrust of the talk. But if Newton were in the room, I think he would have radical disagreement with the spirit in which you've recast his position. I think, the issue here comes when you talk about. There's a lot of issues here, and I'll talk about it in my own talk, and I don't want to give my talk now. But I think the key point here is how you're interpreting mathematics, and you're doing this kind of move of saying that. The point of having mathematical physics, it's a particular branch of knowledge. It has its domain of reality. It's appropriate for its own realm, but it's not everything. It's not laws of nature as a whole. And I understand that. But I think the spirit in which Newton was actually proposing these laws, and this is the controversial point, okay, in terms of both theologically and scientifically, is that Newton thought he was getting in the mind of God. Okay, so that these laws are not, strictly speaking, laws of nature in the sense that you're talking about. That's true. But what Newton thought he was doing was, he had the plan, he had the design, right? He kind of, as it were, second thought God's thoughts. That's what Newton thought he was doing, and he thought mathematics was the language in which that happened. Okay? And that's the radical move, right? And that's a move that's based on a certain kind of interpretation of the idea that we're created in the image and likeness of God, namely that we can think God's thoughts. And that's what the scientific revolution was about, okay? And that's connected with Protestantism, and I'll talk a little bit about that. But it seems to me that's the real issue here, right? It's not an issue of whether you can reconcile Newton to Aquinas, because of course you can, right? But the spirit of the enterprise that Newton was engaged in is radically different from the spirit of the enterprise in which Aquinas was. And so in a sense, the scientific revolution is just another way of replaying the Protestant Reformation. Okay? And that issue is coming back to us now with intelligent design theory. Because I think a lot of the reservations that Christians have, especially Catholics, with intelligent design theory has to do with this revival of this question that's on the table here. And so that, I'll just stop there. And you know.
Well, I think we should remember the truth of the adage, the spirit killeth, the letter giveth life. And I am leery of telling of what the spirit of Newton, what his intention is here. Now, of course, you want to say, well, but look at these texts and look at and so forth, which Newton argues. My point here is not so much what Newton's intention was, because I think you're correct. There would be passages in Newton in which he says things which would be inconsistent with an Aristotelian and Thomistic notion of mathematics. But there are, but if you take, I'm starting not so much with sort of getting into the head of mind of Newton, but rather the mind of the master narrative of the origin of modernity, a way in which the scientific revolution has come to be interpreted. Now, there are, as I said, there are many facets of the interpretation of the scientific revolution. And for example, one could, your thesis here reminds me a little bit of Alexandre Koyré, which is this metaphysical shift from the closed world to an infinite universe and the essential role of mathematics in that shift and so forth and so on. But still for Koyré, the principle of inertia is a particularly key element in that metaphysical shift. Now, I don't deny that in the 17th century, there are fundamental metaphysical changes, especially with respect to mathematics. I mean, you take Galileo's famous remark that the book of nature is written in the language of mathematics and so forth, and you can't understand anything about nature unless you know mathematics, etc., which is inconsistent with some other things Galileo has to say on understanding nature. I'm trying to argue, in one sense, a narrower and in another sense, a broader view. If we want to take seriously the natural philosophy of Aristotle and Thomas, as I think Mariano and Artigas want to do and I want to do, then we must confront a particular understanding of intellectual history which precludes us from taking it seriously. And that's really the focus of my talk today, to confront that master view, which does involve interpretations of Newton and in particular the principle of inertia. I think that one can understand the principle of inertia and Newtonian physics in the way I've suggested as a great expansion in the intermediate sciences without doing a disservice to Newtonian physics, without doing a disservice to the Principia. It might be a disservice to the spirit of Newton. But I'm not so sure, I'm leery of worrying about the spirit of Newton one way or another, huh?
You don't like the spirit of Newton.
No, it's not that I don't like, because I think there are about as many spirits of Newton as there are people who appeal to them, huh?
Bill, I think we're going to have to,
okay.
I want to take two other questions. We'll obviously have to be fairly, first of all, Philippe Dallaire, and then secondly, Russell Wilcock. But I would ask if your question can be relatively brief, Russell, and Russell tends to give another paper when he asks a question.
Well, that's only the spirit of Russell.
Philippe Dallaire.
So thank you for your talk. That is fine. That's okay. Actually, I would like to know, but because if I remember well, St. Thomas of Aquinas accepted an infinity of causal chain elements in the past, actually. So the notion of motion, of space, time was not the same. And so you can say that there is a flaw in the Newtonian or Cartesian view of the world, because they accepted absolute space-time. It is not the case for Aristotle and St. Thomas of Aquinas, which actually, when you see that, you can say that inertia is relative rest, simply. But the difference between the actual cause now of the motion, which is not motion, physical motion, but actually change in the world, because Aristotelian motion is much more like a change, which can be change of color, change of properties, etc. Now, and so if you have in the past, you can have a succession of causes which are infinite. So that's why St. Thomas of Aquinas accepted the non-demonstrability of the initial of the creation in the time. So he accepted that with Aristotelian basis. But he said actually that the chain of causes must be actual, present. That is the motion I'm making today. That's what you were explaining with metaphysical dependency, which is not an action in reaction of successive causes. Otherwise, we'll have the trick of the egg and the hen. The hen, so you can have a problem. No, this is not. You cannot prove anything with this. You can have infinite chain, but metaphysically. But now the chain cannot be infinite with the. For example, if I do have a wagon which is moved by another wagon, and so you must have some locomotive to move all the wagons now. It is not a past event, it is a present event, if you want. So that's why I should say that the comprehension of Blumenberg and Pannenberg of the problem was like the chicken egg problem, which is not absolutely not applicable to the problem of the creation from the point of view of St. Thomas of Aquinas.
Well, two quick points. My criticism of when Blumenberg and Pannenberg say the principle of inertia contradicts the doctrine of creation, they misunderstand what the doctrine of creation is all about. And fundamentally, they make creation a kind of change. And as Thomas said, creatio non est mutatio. Creation is not a change. And that's sort of a fundamental error when they talk about creation and the principle of inertia. I want about absolute space and time. I want to suggest that a mathematically understood world, a world in which mathematical principles are being applied, is an abstract world, and in that abstract world, one could talk about absolute space and absolute time, but the error is to think that such discourse is a discourse in physics or in natural philosophy. If it's a discourse in physics and in natural philosophy, well then for Thomas and for Aristotle, it's a mistaken discourse because it's proceeding from mathematical principles and not from principles in physics. Now, whether or not Newton would recognize that distinction is a different question, but I think there are any number of passages in which he does recognize that distinction. But I do think you're correct that the problem with one of the problems with Pannenberg and Blumenberg, and it's a problem with contemporary discourse about creation and evolution. I mean, evolution is an explanation of change on a grand scale, and creation isn't a change. And so that we have a similar case.
I'd like, if possible, to take the next option. If we can try and do this in 2 or 3 minutes completely.
6.
Russell.
I just gave the answer. 6.
Your thesis seemed to be, correct me if I'm wrong, that one can draw a distinction between the scientific discoveries and or the scientific advances of Newton, etc., Galileo, and the scientific revolution. Revolution is an interpretive spin, which you seem to have difficulties with. But I'm wondering, going back to what Steve Fuller said, in terms of the revolution, in other words, that interpretive spin, do you find it convincing, his argument that, or his suggestion, that that's an outworking of the Protestant Reformation and the metaphysical commitments which underlie the Protestant Reformation?
No.
And if not, why not?
Because I think it's more connected with the natural philosophy of Descartes than it is with the theology of Luther. Although there is one connection, and I'll try to, and this is a thesis developed by Gary Deason in the United States, that the emphasis upon divine sovereignty and divine omnipotence, crucial to the Reformation conception of God, finds a correlative in the inertness of matter, the absence of natures, of qualities which are the source of characteristic behavior in nature, which appears not to need a God. So a mechanistic universe, a universe of nude bodies without natures and characteristic behavior, is more in keeping with a conception of divine sovereignty than an Aristotelian conception of nature. So that theological position does support a particular mechanistic understanding of nature, and that mechanistic understanding of nature is a feature of the scientific revolution, capital S, capital R.
So